All right, so here, hello everyone, and welcome back to SK Monicus, and we're back live for once again. Since it's been too many days that we were live, so here we are, and I'll just guess wait for some messages. All right, so here's the first one, Pranav Sinha. Hi, hi. Nirman Khan, Eid Mubarak. Well, Eid Mubarak. I guess it's been already like lots of days we had a conversation, right? I guess it's been over 2 months. Aisha, Raza, happy Eid Mubarak in advance. Junior Einstein. Well, happy Eid Mubarak. The scientific Z. Hi. Nirman Khan, 1 plus 2 plus 3 plus 4 plus. All right, until infinite equals minus 1 by 12. Yeah, well, I know that. Uh, Divyanshu, hi Sarim bhai. Hi. And यहाँ पे आदेश ज्ञातवंत हाय सर हाय Divyanshu, good evening. Sarim bhai, good evening. Kritik Yadav, hi. And I guess there's just highs and hellos right now. Nirman Khan, 1 square plus 2 square plus 3 square plus 4 square plus until infinite equals 0. Well, ये जो चीज this particular thing that you're squaring up, I guess it kind of seems a little weird when you consider adding the natural numbers until infinite is minus 1 or 12, but squaring them and adding is 0. But I kind of feel the second statement like logical, so cannot say much about that, but I guess that's true. Shivam Kumar, all right, please share book. Well, I don't understand, like recommendations or something. Let's stop the one. Oh, the scientific Z. I have a question in which field would like to proceed your future with? Like being specific, quantum mechanics and specific relativity, like basically a kind of unification of relativity and quantum mechanics. So you might say quantum field theory, or to basically taking it just to the next level, a unified field theory. So I think this latter, which is particularly my ambition, is still a far away dream for the current level of research. Nirman Khan, both are wrong, but both are equally logical to say. Well, I guess the first statement is, I guess, Ramanujan's statement, right? That the sum of all natural numbers is minus 1 or 12. So I'm not sure whether this is wrong or right. Obviously, seems low. But this one actually, what you're saying is, I guess it's true in the converse. Both are right, but both are equally like illogical, seeming to say. और दिव्यांशु सारिम भाई मैग्नेटिक फील्ड की डायरेक्शन निकालने का यहाँ कितना तरीका है कितने तरीके हैं वेल मैग्नेटिक फील्ड के डायरेक्शन निकालने का डिपेंड्स ऑन द सर्कमस्टांस मतलब अगर यू आर कंसिडरिंग इट दिस वे कि आपके पास मान लीजिए एक करंट लूप है एंड उस करंट लूप के लिए एक मैग्नेटिक फील्ड का डायरेक्शन निकालना है किसी भी पॉइंट पे सो यू विल यूज द राइट हैंड थंब रूल कि मान लो यहाँ पे इस डायरेक्शन में करंट जा रही है लूप नॉट लेट्स से करंट वायर फॉर इंस्टेंस इजी इस डायरेक्शन में करंट जा रही है यहाँ पे ओवरऑल यहाँ पे आप कंसिडर करते हो कि यहाँ पे एक पॉइंट है तब इस पर्टिकुलर केस में यहाँ पे जो डायरेक्शन होगा इट इज गिवन बाय वेक्टर ds क्रॉस r कैप वेक्टर ds इज द डायरेक्शन ऑफ करंट क्रॉस में r कैप इज द यूनिट वेक्टर तो ये जो अगर आप देखते हो तो क्लियरली इस पॉइंट पे अपवर्ड डायरेक्शन में होगा अगर किसी चार्ज पे या फिर विद अ सर्टेन वेलोसिटी फोर्स गिवन है तब वहां से बेसिकली वेक्टर एफ इक्वल्स क्यू वेक्टर वी क्रॉस वेक्टर बी या फिर वेक्टर एफ इक्वल्स आई वेक्टर एल क्रॉस वेक्टर बी से मैग्नेटिक फील्ड का डायरेक्शन निकाल सकते हैं Uh, Nirman Khan, we are just equating correctly and wrongly applied versions of rhyme and zeta function. Oh, I see. Pranav Kumar Sinha, what are your thoughts on graviton? Well, my particular thoughts on graviton that if we are able to indeed discover such a particle, so it can be pretty good if we are able to identify it, which will be in fact really difficult. क्योंकि अगर आप देखते हो graviton is first of all supposed to be massless. The second thing that you have to understand is कि gravity force really में बाकी forces के comparison में बहुत ही weak है. तो इसका क्वांटम बहुत ही छोटा होगा जिसकी वजह से इसे वेरीफाई करने में देयर इज गोना बी लॉट ऑफ डिफिकल्टी बट इफ वी आर एबल टू डू इट सो यूजिंग the data obtained from there we can indeed achieve a lot in particularly the unification of gravity with qm. Shivam Kumar sir, please tell me best book for physics beginners. Well, if you are looking for just completely a beginner, so I guess you should start with something like a popular physics book like A Brief History of Time and Elegant Universe. If you are looking for something like a textbook, so I would say a good start would be with something like Resnick Halliday Walker. If you have indeed managed to learn calculus at that level, not just basic level calculus like basic integration and differentiation, but that's it. Shubhanshu, hi sir, hi. Just a piece. Are you looking forward to crack any Olympiads like NSCJS because your science is good? Well, I was particularly aiming for IPHA and all, but what I'm thinking right now is that I may give IPHO like beginning from NSCP, but I'm not particularly sure of now whether I'm actually interested in it or not. And I'm talking about even NSCP and IPHOs right now. Pranav Kumar Sinha, have you completed Principia Mathematica? No, not right now. Mm, and please give solution of Pathfinder, Schrodinger Siddiqui. Well, I haven't studied Pathfinder, and I am not sure whether I'm going to study it or something. All right. Here, Amrita Singh, can you name some ad hoc hypothesis in physics? Well, ad hoc hypothesis in physics, I would say, would be something like string theory. Well, I'm not particularly sure, but you have derived string theory for solving this particular kind of problem of basically unifying gravitation and quantum physics. So maybe the hypothesis that matter at its most fundamental level is not particles but vibrating strings. Uh, Nirdosh Kumar Jha, HC Verma and KC Sinha, which is better? Well, I haven't studied this KC Sinha thing, but I guess HC Verma is pretty good if you are looking for Indian, basically physics textbook that is teaching you 11th and 12th grade physics. Shubhanshu, please make video on Schrodinger Bevy question. Well, I will plan to soon. The Indian racer, hello Sarim, how are you? Well, I'm doing good. Need and solution, sir. Need and solution, sir. Thank you for clearing our doubts. Well, you're most welcome. MBBS motivation. Your plan after 10th. After 10th standard, I haven't decided in specific actually. Nirman Khan, explain how Galilean transformation fails to explain the electromagnetic theory of light. Well, according to the Galilean transformation, what you can say is that basically imagine it basically uses the ideas of classical space and time. It's something like this: you are going in a train. So in that particular frame of reference, you are viewing an object with certain velocity v going, let's say, in a certain direction. If the train is also propagating and basically going in that direction with a velocity v naught, so for an inertial frame of reference at the platform, according to the Galilean transformation in that classical web of space and time, you'll see the velocity of that object, let's say, for instance, a ball, as v plus v naught. If it were light, so light would as well have a velocity v plus v naught in the basically Galilean transformation. On the other hand, electromagnetic theory of light states that for whatever medium you have, the electric and magnetic fields are all oscillating back and forth and creating these electromagnetic waves. And then what you can say is, then what you can basically say is, since this is contradicting the electromagnetic theory of light, which was more of a modern theory than Galilean transformation, so it actually fails to explain that electromagnetic theory. So Lorentz transformation, on the other hand, uses a more modern way of space and time, like the length contraction thing, the time dilation, how time is actually changing for frames of reference. All right. Lols. Prove 1 plus 1 equals 2. If you can't, how can you say maths is true? Well, that's the way it is supposed to be. Like you particularly decide this one thing, you particularly are deciding this one thing, and then from as a consequence of this, all else is falling. Like I remember this quotation I once read: freedom is the freedom to say 2 plus 2 equals 4. If that is granted, all else follows. So you're basically stating a particular thing which you believe is true according to the classical models, and according to that, everything else is proceeding. Can you explain the space model presented by Tolmi, Amrita Singh? Well, what he particularly thought was something like this: that the Earth is basically the center of the universe, and all the planets and the stars and the suns are orbiting around the Earth. And in this particular model, it was more or less tried to be consistent with the Bible. That is why the Catholic Church adopted this model, and they were against anyone who were kind of in opposed to this particular web. So, including Galileo, who was house present just for the fact that he stated that Earth is not at all in this particular condition, that it is the center of universe or something like that. But still, you'll see there are a lot of even flat earthers, right, to this date. Schrodinger Siddiqui, do you study mathematics also? Well, I do. Pranav Kumar Sinha, what have you studied first, relativity or quantum physics? I first learned relativity. I'm still not that good at quantum physics, to be very honest. Sandeep Sarkar, how would you explain the about kinetic energy to a fifth grade student? To a fifth grade student, I would explain kinetic energy as something like this: that anything that you are seeing is you, anything you're seeing is moving around you. When let's say it collides with another thing, so it basically what it does is influences that other thing to move as well. Let's say you have a ball over here, you have another ball over here, this ball moves towards this ball with a certain speed. What basically happens when this ball collides with this ball, so we know this as well starts moving. What basically happens is that this ball has a certain number assigned to it. Let's say a certain number assigned to it. When it collides with this one, so it shares this amount of number equally, and definitely not necessarily equally, so that the sum remains just as the original number. This particular number that you have for the motion of any object is kinetic energy of this. So that is how I would basically kind of explain it. Can sound waves generate heat? Amrita saying. Well, you see, sound waves is basically how the sound propagates. It is just a kind of disturbance in these molecules. So obviously, they are indeed creating heat. They are indeed creating heat because as they are propagating, you will see there is change in kinetic energy. There is friction between the molecules. So that is indeed heat produced. All right. And Ayush Pratap, in which class you study? Well, currently ninth standard. Study Sci, maths. What will you give at Olympiad or JE and when? If anything, then I would go for Olympiad. And when I haven't decided, maybe ninth standard, but I doubt I'll be eligible in ninth standard for that. So maybe 10th. Uh, Ankan, all right. Ankan Banerjee, NEET aspirant. Sarim, please explain that why potential energy is not defined while change in potential energy is defined. Potential energy is not defined while change in potential is defined. So look, what it basically happens is that when you do work on a certain object, so you can assign potential energy to the states of the system at particular points, that this particular object is present at this location in the system, then it goes at this location in the system. So potential energy, the concept itself is defined with the way that when it goes from here to here. So for this, for such a, like, let's say, force that it goes from here to here in such a way that whatever path it is following, then the force will always have the equal work for both the points. So what you can say is these 2 points have a specific number assigned to them whose difference always remains constant. So the concept of difference of potential energy and thus potential comes from here. Regarding the potential energy or potential itself, you cannot define it because the choice is arbitrary. The work then in going from here to here and when you're calculating it and vice versa. So you will see that even if you add any arbitrary constant to the potential here and the potential here, it won't change the value. That is the reason the concept of potential energy and potential is strictly defined for any particular change of state, or rather change, but the concept of potential energy or potential itself is not strictly defined. Jayanta Mashanda, Sarim, can you please tell me Michelson-Morley experiment? Well, I shot a video about the Michelson-Morley experiment few days ago, so you can check that out. Uh, रोशन वर्मा, आप कभी राजवंश सर से फिजिक्स पढ़े हो? वेल एक्चुअली नॉट. Ronak Pandey, what you thought about chimney question? I shot a video on that question and the answer was 47.1 gram per second, I suppose. And as for the second, the answer was something like 18, if I remember correctly. So you can watch my video over that particular problem. Arnav Gupta, hi, which books should I read for general physics? Depends on what you mean by general physics. Vishnu Galav, what is your future goal? Well, research in physics. Sandeep Sarkar, how can I gain knowledge that you have? Well, just study as hard. Nirman Khan, if a complex infinite sum with each element z converges, then does the infinite sum with each element mod z converge? Well, if I have to explain it, so let's say you're representing the complex number by x plus iota y. So for this particular number to converge, like you're adding x1 plus iota y1 plus x2 plus iota y2 plus x3 plus iota y3. So for this particular, like let's say infinite complex infinite sum that you have over here is x1 plus x2 plus x3 until infinite plus iota y1 plus y2 plus y3 until infinite. and it is converging to a certain point, right? So the mod of z over here, if I look at it, I doubt whether that will converge, because the mod of z, so that's like root of x1 square plus y1 square plus root of x2 square plus y2 square. I actually doubt whether that will converge. So if I am wrong, please correct me. Arnav Gupta, more like Stephen Hawking books. I mean, well, A Brief History of Time is always there, and you can read Elegant Universe, which I personally liked a lot, by Brian Greene. You might read something like Kip Thorne's Black Holes and Time Warps, though that is a little more advanced than these, even though that is still for more like popular physics book, and that is, you might read some more like Stephen Hawking wrote brief answers to the big questions. That was pretty good. Gaurav Mandal, how to solve motion in a straight line numericals? The way you solve all other kinds of numericals, you have to know the concepts for that particular thing. You have to be able to carry out the enough mathematics of it. Just have some patience and just do it. In case you are not getting, so maybe you're not able to apply the proper concept into it. So you might see the solution for some of the questions, but it's always better to try yourself. All right, so here was Savage. How do you remember topic by just reading a heading? Please reply. Well, I don't remember the topic by reading just a heading. Like, if I, let's say I am learning some kind of topic, let's say Lagrangian equations, for instance. So I cannot just remember it by reading the heading of that particular thing. Rather, you have to go through all that mathematics and you have to go through all that concepts by doing it, and then only you can remember it. Roshan Verma, you can learn physics from Rajwan sir. You can came love with physics. Actually, regarding it, I have seen some of the videos, but what I personally believe is that majority of the time, whenever you will watch someone's lectures who is actually teaching for a competition, so that isn't really physics the person will teach. Physics is more like being able to intuitively imagine that particular concept and being able to tell that whether that there is a minus sign there, so what does the minus sign signify, or there is a particular term there, so what does that term in fact signify. So I would rather watch something like Walter Lowen's lectures, and there are also some of Feynman lectures available on internet if you see. And Feynman lectures, the textbooks are always there, the bibles of physics. So, to actually love physics is being able to understand the concepts intuitively rather than being able to solve some questions. Nirman Khan, did you solve that magnetic field problem that I solved? Well, I don't remember which problem are you talking about. I guess that was something that Satyam Bhai had sent long ago. So, are you talking about that? Roshan Verma, keep your attitude aside, please. Well, what are you talking about? Nirman Khan, no, that's not the one. I made another magnetic field problem. So I would be glad to have a look at it. So you can send it and I can have a look. Another thing is I'm not using WhatsApp. So if possible, Discord would be another thing. If a force of 3 Newton is applied on 2 kilogram block, then what will be the force of contact between the two blocks? So you're using a block to apply a 3 Newton on another block. So the force of contact in that particular case will be like, if I'm getting the question right, because it is not, I guess, explained properly over here. So what you can do is that in this particular case, In this particular case, as I'm getting from whatever context I'm able to understand, it will be again the same amount of force that you're applying, 3 Newton. Physics by Nikunj Vyas. Hi, I'm also in class 9th and my hobby is to study physics, and so I read physics of class 11th and 12th, and and now I'm reading Q Physics, and I have an YT channel of name Physics by Nikunj Vyas. Well, that's good. Shubhanshu, AC and DC current, which intensity is high? Well, depends on what the particular values for them are, and it also depends on what do you mean by intensity over here exactly. Vikash, can't please reply करो. Well, I didn't actually read. Okay, आप कितने साल के हो? आप कितने साल के हो? Please बता दो. Going to be 13. Sandeep Sarkar, is gravity a force? Well, in the classical physics, gravity is indeed a force. In general relativity, it is more like a defined, let's say, warping of space-time that you have over here, a kind of curvature in space-time, and then this kind of curvature is basically creating whatever that you have. What is a reflected index? In any case, do you mean refractive index? Shivyansh Patel. Refractive index is basically something like it is a kind of property of every medium that every medium has. And this property is something like that slows the light down in that particular medium. For vacuum and air, it is nearly one. For vacuum, that's an exact one. Air, nearly one. And it's basically the speed of light of the in vacuum divided by the speed of light in that material. So always greater than 1 for whatever medium. All right, Shubhanshu, thanks for reply. Well, welcome. Amrita Singh defines Snell's law. Snell's law of refraction is something like this, that you will see if in case any light is propagating from one medium to another, then according to the relation of refractive index and the velocities in different mediums, it is basically n1 v1 equals n2 v2. That is, in this particular case, the velocity of light, if you are seeing over here, the velocity of light times the index of refraction in that particular medium is exactly a constant. Rita Sinha, what is Gauss's law? Gauss's law is Gauss's law is basically something like this, that if you have a closed surface over here, let's say a closed surface, then the total electric flux, net electric flux, something that is coming out of that particular closed surface or that is entering the net electric flux is basically the net charge present inside that closed surface, which is called a Gaussian surface, which is again an imaginary surface over a constant of nature, which is epsilon naught, the permittivity of free space. What are Raja Masood? What are the actual equations of motion? Not V equals U plus AT and all. Well, equations of motion is such a term that is used for a wide variety of let's say objects that now not objects, rather equations. If you are looking over here, but particularly to be very honest, equations of motion is basically the equation that is governing this entire thing, that is governing the motion of that object. So for a free particle, for a particle experiencing a force, a equation of motion would be something like vector F equals md vector v over dt. And the reason I'm saying d vector v over dt instead of vector a, it's particularly because vector a is something like that is defining the acceleration, but again it can be gone with force over here. What particularly we are interested is knowing where the particle is, that is the position vector, or with what velocity it is going, the velocity vector. So that would be an equation of motion over here. Ertugrul, your chashma is concave or convex? It is more like a polarizer, in fact. It polarizes the blue light. Saheed Ali, sir, please define Young double slit experiment. Young's double slit experiment is something like this, that imagine you have the light waves coming from here, then you have such a kind of a screen over here, or not a screen, let's say a wall for an instance, and then you have two slits in that, a screen over here. When light passes, it doesn't go, in fact, just how particles of light would go if light were a particle. It goes over here, it is separated from here, and what you will see is resulting something like this, that what the resulting effect after coming out of the slit, what you will observe is something like this, as if two sources of wave fronts or light waves are in fact here. When they go out, they go basically at the screen, and the kind of way they are behaving is interfering with each other. The waves are interfering with each other, and you might see interference patterns of dark and bright fringes over there. So that is the Young's double slit experiment, which proved that light is a kind of wave. But now we all know it depends on the frequency of oscillation of that particular EM field, whether it is a wave or a particle. Sandeep Sarkar, why fire doesn't have a shadow? Well, fire doesn't have a shadow. It's because it is a source of light itself. Shivraj Singh, what's your plan in future? Because you're gonna get AIA 1 in JE Advanced. Well, thanks for that, but my particular plan in future is more research aimed. So just wanna do research. Rita Singh, is the universe infinite or just very big? Well, the universe is just very big. It cannot be said infinite yet. What class are you studying in? Vishal Karn. Right now, ninth standard. Avinash Hatte, what is the kinetic energy of a rotating body? Well, kinetic energy of a rotating body, let's say it's just rotating, for instance, then what you can say is that is the half times the moment of inertia about the axis it is rotating times the angular velocity square. Nawal Jaiswal, how to improve physics zero level to high? Well, it is by just reading more and more, thinking about it more and more, and trying to apply it to your everyday life. Amrita Singh, can you define Edwin Hubble theory about space? Edwin Hubble theory about space is basically that the universe is expanding, and he found it by looking at the, let's say, stars out there and knowing that they are in fact going away from us. And how he found it was using the Doppler's effect, that the frequency of light, that light is getting to the redder side. The wavelength of light is in fact increasing, not the frequency, but the wavelength of light is increasing. That is possible when the objects move farther apart. So that was his theory, that the universe is expanding. निर्मल खान, तुम लोग ही पढ़ो. वेल, पढ़ो what? Abhishek Kumar, what do you think about light speed engine? Well, to actually accelerate something to a speed of light is practically impossible. Rather, in principle, it is impossible, even in principle. So, what you can say is a speed light engine would be more accurately something like this, that isn't exactly accelerating something through, let's say, through space to the speed of light, but it might be able to, let's say, take that particular spaceship, let for instance, into kind of hyperspace, and then it might be possible there, right there, to actually travel faster than speed of light. But to be able to propagate through space faster than light, or to at the speed of light, is not possible. Physics atom Lakshya, hello Sarim, I have a question for you. Well, be sure to ask over here. Explain me horsepower in simple terms. Sir Sandeep Sarkar. Horsepower is basically a kind of unit, if you look at it, of power. Nothing more, nothing less. It's basically a unit that you have. Manas Bhatia, are you interested in astrophysics? Well, yes, kind of. विशाल कर्ण कौन से कंट्री से हो? इंडिया ओनली. Great Sinha, what is displacement current? Well, displacement current is, let's say, displacement current is a specific kind of current. Let's say you are going through a capacitor over here that is being charged. So all over here, if you're looking at it, the capacitor is obviously being charged, and there is current propagating. That is called that is basically the propagating current you have. That is called the induction current. When you look through between the place of the capacitor, there is a still magnetic field over there. Obviously there is all around this particular thing magnetic field, but this particular magnetic field that you have, it needs to have this current in this direction to be able to produce the magnetic field at those points. So this particular current that you have over here is displacement current. Many people often say that it is something like an imaginary concept to be able to fill in the gaps in our ideas, but it is not at all such as that. Displacement current actually exists. It actually exists in a sense that the charge, as this particular capacitor is being charged by a battery or whatever, it is a true concept in the sense that as the charge is flowing, so you might be clearly able to see that the charge on one side is increasing, on the other side is decreasing. So through this particular space, the charge is indeed flowing without the help of any wire or anything, in the sense that the charge on one side is increasing and the other side is decreasing, the positive and negative sides. That's the displacement current. And the idea was introduced by Maxwell in order to improve Ampere's law. Shivam Jango, if action and reaction are always equal, then explain how can a horse pull on cart? So that's basically the work of friction, in fact. Light has mass or not, Aman Yadav? Well, the concept of mass, if you look at it, isn't that necessary to be able to define for light, as per I believe. Light indeed has momentum. So if you look at it, the way light has momentum, it is not necessary to have mass in order to have momentum. Rather, what's more necessary is the energy. So light doesn't necessarily have, if you look at it, a kind of rest energy, as it does not have a rest mass. But since it is an electromagnetic wave, it definitely carries energy from one point in space to the other. And by the factor of this energy, according to E equals PC, it has the necessary momentum. Aditya, I'm a JE aspirant. Give some advice. Well, regarding if you are JE aspirant, so I would say, particularly for mains and advanced, also it is very necessary to be able to improve your concepts. So try improving your concepts, and accordingly try improving your problem solving skills. Also, whatever topic you are studying. And I would say that many people often say don't study from textbook, study just from my notes or the modules of your coaching or whatever, but I personally believe it is always necessary to be able to study from the textbooks, because when you study from textbooks, you are basically putting in that all information into your brain all by yourself. So you'll be able to retain it much better than by just solving numericals and learning theory from some notes or modules. So always remember to study from textbooks. Sahid Ali, sir, please give idea how to learn frequency and wavelength of all types of electromagnetic waves such as gamma rays and X-rays, etc. Well, don't ask me about that. I haven't exactly learned, let alone frequency. I haven't exactly learned even the wavelengths of all these things. In fact, I haven't even learned the order of all it, the gamma rays and X-rays. I guess gamma rays and X-rays are one on higher side, right, of frequencies. They're on higher sides of frequencies, right? Lesser wavelengths. I usually don't retain such kind of information. I don't learn such kind of information. Lakshmi Narayan Jogo. How is kinetic energy equal to charge times potential? Well, kinetic energy equal to charge times potential. Usually, most of the time, I keep track of learning only the fundamental formulas that are defining or the result of some very important factor over there, consequence, not basically these derived results. But kinetic energy to be able to equal the charge times potential. If we look at it, kinetic energy is definitely something like the change in kinetic energy is basically the work done in going from one point to another. So the work done by electrostatic force over here, let's say for instance, work done by electrostatic force will be clearly equal to, if we look at it, the work done by electrostatic force will be the electrostatic force itself times the displacement. The electrostatic force itself, you can clearly write it as something like the potential difference over this particular thing, that is the distance over which you are evaluating the potential difference times this distance that gets cancelled. So you have potential difference, and also keep track of this thing, the charge over here, because the charge factor is important when you are evaluating the work and the force over this particular thing. So I guess in the end you are basically coming to this thing that the kinetic energy would be the charge times the potential difference, rather charge times potential difference, and that is also in fact change in kinetic energy, that is charge times potential difference. Sayona Dash, your galaxy also revolves or rotates. It indeed rotates, and it also revolves. Revolves that it is going all basically around our universe. Not exactly around our universe, that it is orbiting with a certain time period or something, but it is basically moving across the universe and rotating as well. Nawal Jaswal, what is your revision technique? Please share. Well, I don't basically revise. Shivam Jango, dead body floats over water, but alive person sinks in water. Well, alive person sinks in water, dead body floats in water. So it definitely has to do with this thing. That's the density. Density of a dead body is obviously lesser than the density of water itself. So that might be because the body gets inflated, I suppose. Omni Speak suggests some physics books to learn physics. So to learn physics, I would suggest obviously a brief history of time is always there to be begin physics, and other books to study physics like Resnick Halliday Walker or Resnick Halliday Crane, if you might go- pick between these two. And other books are like Feynman Lectures on Physics. Shreyash Sinha, hi bro, I wanna just know how many books of physics you have finished up till. Well, the number of books I have finished until now, what you can say is that you can just watch my video over the topic, like where I have shown my physics books. You can watch the recent latest videos about the topic. Like I have basically shot many, so you can watch them. Ramja 123 Lakhan Jha, Sarim, you study H.C. Verma first. Well, I studied that in the very beginning. Oh, Amrita Singh, why do ship float if iron sink and ship is made up of iron? Well, if you consider the interior of ship, so you'll see there's lot of air inside. So since there is lot of air inside, then just and it is not completely made of iron. Like there's iron at the surface, and in the interior there's air. So whatever the total mass over volume ratio is, that is the density of the entire ship goes down. Then the density of pure iron is obviously greater than the density of ship due to the air factor in the ship. That is the reason. Nawal Jaswal, if you not revise, then how to remember for a long time? Well, I guess anyone else should definitely like revise. It's important to revise. In fact, when you're preparing for a competitive exam, regarding myself, I don't revise, and how I remember for long because I'm always at it. I'm always learning new and new physics concepts and all this thing. So that is the reason I can retain for a long time. Sandeep Sarkar, what is drag coefficient? Well, if you consider any object that is moving through a fluid or something like that, so a fluid always exerts a retarding force on that object. So that is this particular coefficient, a constant of proportionality that you have for the force exerted on that body. That is the drag coefficient. Where the electromagnetic wave generate, Shubhanshu? Well, it is basically the oscillation of charges that you have over here. The way the charges are oscillating and the oscillating electric and magnetic fields that you have. That is just how the electromagnetic forces generate. Divyansh, how to be astrophysicist? To be astrophysicist, of course, you need a good understanding of physics and mathematics. So a bachelor's degree in astrophysics, a master's and PhD is how you do it. Iman Deka, Kirchhoff voltage law, please explain having problem. The Kirchhoff voltage law, to be able to understand this particular thing, is understand it this way that Kirchhoff's voltage law is in fact nothing but the application of conservation of energy to DC circuits. It's nothing but the application of conservation of energy. What you do is that imagine you have this particular thing over here. This, let's say, a particular kind of DC circuit. You take a point in the wire and you revolve around a charge. Let's say you are a charge. Let's say, for instance, you are a charge and you're going all around the circuit. And when you return to that particular point, energy must be conserved. Since energy must be conserved, it is not being dissipated anywhere in particular. When you're keeping in account the fact that you are basically a charge, you're passing through a resistor. As long as that current is maintained, the flow, your flow itself, since you're a charge, is maintained. So when you pass through a resistor, you obviously lose energy. But on passing through the EMF source, on passing through the battery, you gain back that energy. Since you are gaining back that energy you're losing in the resistor on in the wires, the total energy over here is constant. So when you are leaving over here and when you return to that certain point for once again after completing a cycle, you are saying that the energy you lost during the process is again the energy you gained during the process. So overall, the energy remains constant. Since the energy remains constant, here the work done is zero. Work done on you in particular. Work done is zero, so the potential difference across this entire thing must be zero. Understand it this way as well, that when you are traveling across it, so upon basically encountering the same point again, the potential difference must be zero. That is Kirchhoff's law. So here potential is constant for that particular point. That is what is basically happening. Iman Deka, thanks bro, cleared. Well, welcome. Shivam Django, why raindrops have constant speed or velocity? Well, the reason is because when they are basically coming over here, they have already gained their terminal velocity that they can't accelerate further. The air drag is pushing them up, the gravity is pulling them down. They've already gained velocity enough that this air drag is countering the effect of gravity on it and they can't accelerate further. Shubhanshu, positive and negative both charges generate electromagnetic wave. Yeah, well, they do. Uh, Harsh Yadav, how to study physics of class 11 for freshers? Well, you should be well acquainted with the mathematics that you need to have for covering class 11 physics, like basic calculus and all that stuff, trigonometry and coordinate geometry and all this stuff. And then you just start with whatever textbook you are picking up. And you might feel down at certain points, but keep up. That's how you do it. Nisha Tripathi, why Earth is round? The earth is round for the reason that gravity is all there in whatever dust and rocks earth is formed of. Gravity is pulling all these materials inward to the point that it wants to reduce this entire surface area. And for the most reduced form of this kind of area that you have over here is for a square. That is the reason earth is a square. And indeed it is not completely a square. Since it is revolving, there are some centrifugal effects on the equator of earth which is kind of pulling it a little bit out on the equator side. That is the reason there is a difference of 21 kilometers in radius from the equator to the poles. Uh, Shivam Django, is gravity decreases as we go down in Earth? Well, gravity kind of, yes, decreases as we go down the Earth, because if you're at a certain point, the remaining portion of Earth will pull you down, but the upward portion will pull you up. That is the reason overall gravity decreases. Nisha Tripathi, why every planets are round? Well, for the same reason I told you, uh, again, same person, why sun is round? For the same reason as I told you, as for why the earth is round. Harsh Yadav, how to remember anything? By reading it and then revising it from time to time. Manak Kohli, what is it about your research and theory of everything? I do want to hope pursue my research career in the field of theory of everything, at least contribute a little bit in here in the theory of everything. So that is obviously my plan. Mahesh, plan on representing India in IPO? Well, IPHO in any case, if you need. So I kind of did have plans for IPHO and I hope I will do it. What the force is energy, Subhanshu? Well, I didn't quite get it. Ramu Jayanti, are you perfect with all concepts of physics till 12th? Well, I guess no one is perfect till any level if you're saying with all concepts of physics. But regarding, yeah, I am good at everything. Like if we consider 12th standard, Sahid Ali, sir, please explain Zorin's law. Well, I'm really sorry for that, but I haven't studied this yet. What is actual reason of tide in sea, Abhishek Kumar? It is basically the pulling of moon's gravitational force on whatever water you have, and that is how the tides are formed. Hemant, hi bro, hi. Who is responsible for electron spin? Sohan Singh. It is an inherent property of the electron actually. We like chemistry also, Nisha Tripathi. Well, I actually don't study chemistry. And I guess that's it. Like, then there's been enough chats, and it's been kind of late as well. So, guess I'll just conclude the stream at this point only, and then we might continue again some other time. And that was all for today. And thanks to all viewers, and bye.